Throughout this video, I'm just going to assume that capital F of x is the antiderivative of small f of x, or small f of x is the derivative of capital F of x. So you might remember from the chain rule that the derivative of capital F of ax, where a is the coefficient of x, is going to be a times small f of ax. This is from the chain rule. For example, we know that the derivative of sine x is cosine x. And so the derivative of sine of ax is going to be a times cosine of ax. Let's go back to this equation now. If we integrate both sides with respect to x, we know on the left hand side that the integral cancels the differentiation, and what you get is only f of ax. Whereas on the right hand side, we just want to keep the integration symbol. We should get that capital F of ax is a times the integral of small f of ax dx. So now I want to divide both sides by a so that the right hand side only has the integral and no coefficient. And what we get is 1 over a times big F of ax is the integral of f of ax. This gives us a rule to integrate a function where x has a coefficient. So the integral of small f of ax dx is going to be 1 over a times the antiderivative of that function plus c. So let's do some examples. We know the antiderivative of the cosine function is the sine function. But you see there's this 3 coefficient here. So I can quickly write 1 over 3, because using this rule 1 over a times sine of 3x plus c. Similarly, for the next example, we know the antiderivative of the exponential function is just exponential function. But this exponential function has a negative 2 coefficient. So I'm going to divide by negative 2. So 1 over negative 2 times e to the minus 2x plus c. You may also remember that the derivative of big F of x plus b is small f of x plus b. That is, when f has something added or subtracted to it, in this case we are calling it b, then it does not really affect the derivative. For example, the derivative of sine of x plus b is cosine of x plus b. Now we are going to integrate both sides and see what happens. As before, the integral cancels with the derivative on the left hand side, and we get f of x plus b equals the integral of small f of x plus b dx. And again, this gives us a rule to integrate a function where you have something added to x. That is, the integral of f of x plus b dx is capital F of x plus b plus c, where capital F is the antiderivative of f. So let's do some examples here. We know that the negative cosine function is the antiderivative of the sine function. And so we can write this as negative cosine of x plus 3 plus c. Similarly, we know that the next one, dx over x plus 5. Now, as you know, this is the same as 1 over x minus 5 dx. And you know that the integral of 1 over x is ln x. So the integral of 1 over x minus 5 is going to be ln of x minus 5 plus c. Combining both the rules that we learned, we can see that if the derivative of big F of ax plus b is a times f of ax plus b, which just follows from the chain rule for differentiation, following a similar procedure and integrating on both sides, we should get that the integral of f of ax plus b dx is 1 over a times big F of ax plus b plus c. This is a very convenient rule to know because it is very common to see a composition of functions where the inner function is a linear function, for example ax plus b. So let's do some examples to apply this formula. We know the antiderivative of the sine function is negative cosine function. So this is going to be negative, but you see this coefficient. The coefficient of x is 3 and the 7 does not matter over here. So this is just going to be negative 1 over 3 cosine of 3x minus 7 plus c. Now for the next one, I'm going to rewrite this to make it easier to understand. This is the 2x plus 5 to the power of negative half dx. And here we are just going to apply the power rule, but we have to divide by 2 because the coefficient of x is 2. So I'm immediately going to write 1 over 2 times the antiderivative of something to the negative half is that thing to the power of half over 1 half. So we get 2x plus 5 to the power of half all over half. And now we can see that the halves cancel over here and we can write plus c. For the next example, we're going to rewrite the 1 over cosine squared function as a secant squared function. So we get integral of secant squared 7x dx. And this is a standard integral. Integral of secant squared function is the tangent function. And so this is going to be 1 over 7 times tan 7x plus c. Finally, for this one, we have the integral of 1 over 5 minus 2x. As we know, this is the natural log because the integral of 1 over x dx is ln x. This is exactly like any linear function. If I rewrite this as 1 over negative 2x plus 5 dx, here your a value is negative 2 and your b value is 5. Since we have a coefficient of negative 2 here, we'll have to divide by a negative 2. So we have 1 over negative 2, which is negative 1 over 2, times ln of negative 2x plus 5. Let's not forget plus c. Now the next example is slightly challenging because we have the integral of sine squared x. And this does not match the format that we are used to. If this was sine 2x or sine 7x or something, that could work because you just have a coefficient of x. But this 2 is not a coefficient. It is the sine function squared. And we are going to use a trig identity to simplify this integral. If you remember, the cosine 2x identity is simply 1 minus 2 sine squared x. We can solve for sine squared x over here, and we should get sine squared x is going to be 1/2 minus 1/2 cosine 2x. You can verify for yourself that this is true. This helps us integrate the sine squared x function. So we have the integral of 1/2 minus 1/2 cosine 2x dx. Now, as we know, the integral of half is just half x. So we have half x minus. Now remember, the integral of the cosine function is the sine function. Because x has a coefficient, we will also have to divide by 2. And so we have 1/2 times 1/2 sine 2x. And 1/2 times 1/2 can be 1/4. So we have half x minus 1/4 sine 2x plus c. Alright, so here are some examples for you to practice. As always, the answers will be revealed in a few seconds. So pause the video and try them out on your own.